We will take up Physics Class 12th, Lesson number 3, Current Electricity. This is Book NCERT Part 1. In this chapter, we will take a small topic, series and parallel combination of resistances. We are going to solve the numericals of this topic. In the chapter Current Electricity, there are certain exercises given and certain additional exercises which are given. So this is question number 3.20 of additional exercise. Let us read and understand the question and solve it. Given n resistors, each of resistance R, how will you combine them to get the maximum? First part, and second part, minimum effective resistance. What is the ratio of maximum to minimum resistance? Now this means you have a lot many of resistances, n number of resistances. The question is you have to combine them yourself and get the maximum value of the equivalent resistance. In the first part and second part, get the minimum value of equivalent resistance when you combine those n resistors. Now we have the knowledge of series and parallel combination resistances. We know that when the resistances are in series, they are simply added together. If we have two resistances R1 and R2, the series combination is simply R1 plus R2. And if these two are connected in parallel, it is 1 upon R equivalent is given as 1 upon R1 plus R2. That means if you add them in series, the value increases. So the part of the question where we are asked to find the maximum value of resistance means the resistances should be connected in series to get the maximum value of combined resistance. So let us solve it. For solution, first part, for getting maximum, for maximum resistance, maximum effective resistance, okay, effective or equivalent means you are combining it and getting it. We connect all the resistances in series. This is the first part of the question. Let us try drawing it and solve and get the value of it. Okay. This is our first resistance, second resistance, third resistance, and so on till n resistance. Okay, and these are connected, of course, to the terminal of the battery XY. Okay, let us see. This is X and this is Y. This is R. Since all the resistances are same value, so all are R. This is first, second, third up to n resistance. So let us find the value of R maximum. R maximum is given as addition of all this. So R plus R plus R plus up to n times R. So it becomes NR. So this is the value of maximum effective resistance. Second part of the question, minimum effective resistance. So for minimum effective resistance, we connect all resistances in parallel. Okay, this is for minimum effective resistance. For maximum effective we get NR. For minimum effective we connect all the resistances in parallel. Okay, let's draw the diagram. How does the circuit looks like? From the X terminal we have one resistor, second resistor, third resistor up to n resistor, and all these are connected together, and this is Y terminal of the battery. Okay, so this is R, 1, 2, 3, 4, n, like this. We get the value of effective resistance as, remember in parallel we get 1 upon R equivalent is 1 upon R1 plus 1 upon R2 and so on. So similarly 1 upon R plus 1 upon R plus 1 upon R n times 1 upon R. So this is N upon R, right? This is 1 upon R minimum, but we are asked to find the R minimum, so we will take inverse of it. Okay, so R minimum is R upon N and the maximum value is N times N. Now the third part of the question, what is the ratio of maximum to minimum resistance? Okay. Third part, ratio is given as R maximum upon R minimum. The value of R maximum is NR and it is R upon N. So R and R gets cancelled, N goes in the numerator and we have the ratio to be N square. So this is the answer which we are getting. Let us now take up question 3.20 part B. Given the resistances of 1 ohm, 2 ohm and 3 ohm, how will you combine them to get an equivalent resistance of 11 by 3 ohms, 11 by 5 ohms, 6 ohms and 6 by 11 ohms? Now let us understand the meaning of the question. The question says you have 3 resistances whereby you have to put 1, 2 and 3 ohm resistances into series and parallel combination such that the equivalent resistance of the combination is 11 by 3, 11 by 5, 6 and 6 by 11 ohms. So let's start with the first part of the question. The first part says we need to get 11 upon 3 ohms. So for that we will draw 2 resistances in parallel, and with this parallel combination we will draw 1 resistance in series. This is the XY point. If this is 1 ohm, this is 2 ohm and 3 ohm. Let us check what is the parallel combination and series combination of the given network. So 1 by R equivalent of these two is given as 1 upon 1 plus 1 upon 2. That makes it LCM 2 plus 1. This is 3 by 2 ohm. Okay. So R equivalent is 2 upon 3 ohms. Now this is 2 by 3. Now this 2 by 3 plus 3, let us see what is the value. So R equivalent is equal to 2 by 3 plus 3, that makes it 2 plus 9. So here comes the value 11 by 3 ohms. This is the required value. Let us go to second part. Second part says you need to have the equivalent value as 11 upon 5. So let's draw the diagram for this. We have the starting point X. From here, if we now take 2 ohm and 3 ohm in parallel to each other and join the 1 ohm resistance in series with this combination, this is XY, then let us see what is the value of the equivalent resistance we are getting. Okay. Now these two are in parallel, so their equivalent resistance will be given as 1 by equivalent is 1 by 2 plus 1 by 3. That makes it 5 by 6 ohms. So which means R equivalent is 6 upon 5 ohms. Now this 6 by 5 is in series with 1 ohm. Okay. So the equivalent resistance, now the combined resistance becomes equal to 6 by 5 plus 1, that is 6 plus 5, that makes it 11 upon 5 ohms. So if you want to get 11 by 5 ohms, you need to connect the given resistances 2 and 3 in parallel with 1 ohm in series. And if you want to get 11 by 3 ohms resistor, then you need to connect 1 and 2 ohms in parallel and 3 ohm in series with each other. Now let us take the third part of the question. You need to have 6 ohms. Okay. So third part is 6 ohms. We can get 6 ohms directly by connecting 1 ohm, 2 ohm and 3 ohm resistance in series with each other. Okay. Here the resistance will be simply addition of all these resistors. So that makes it 6 ohms. Okay. Now the last part, 6 by 11. So one series we have. Let us try the parallel also. We put all the three resistances in parallel with each other and check the value. It is 1 ohm, 2 ohm and 3 ohm. Let us check this value and see what values we get in the combination of resistance. For such a parallel combination resistance, you know the equivalent resistance is given by 1 upon R equivalent is 1 by 1 plus 1 by 2 plus 1 by 3. Okay, so LCM 6, this is 6 plus 3 plus 2, that makes it 11.6. This is 1 upon R equivalent. That means the equivalent resistance of this parallel combination is inverse of it, that is 6 upon 11 ohms, and that is what is required. So you can see if we are given three resistances, we can just rearrange the combination of resistances and get different equivalent values. If we put 1 and 2 in parallel and 3 in series, we get 11 upon 3 ohms. If we put 2 and 3 in parallel and 1 in series, we get 11 upon 5. And if we put all of them in series, we get 6 ohms. And we put all of them in parallel, we get 6 upon 11 ohms. So that means how we connect the resistances makes the combination having different values. We are taking up Physics class 12th, lesson number 3, current electricity. In this chapter, we'll take a subtopic, series and parallel combination of resistances. We are going to solve the questions of the combination. We are taking up additional exercise of NCERT book part 1. The question number is 3.20. Part C. We have already done part A and B. Let us understand the question. Determine the equivalent resistance of the networks. There are two networks given, A and B, and we have to find that if we have to find the equivalent resistance. How do we go about it? Now you can see it is a mesh of resistances, and it's not always that all the resistances are connected in series or in parallel. They are the combination of series and parallel circuits. So in this case, you don't have to go for the solving this plus this plus this, and it's actually very easy to solve because you see it is a symmetrical circuit, and all the circuits which are symmetrical are easy to solve because you just have to solve one part of it and apply it to the other parts. How it is to be done? Let us see. Let me write the solution. Okay, now in the solution I'm going to take just this part, okay, this much part. I will redraw it because this is a part which is repeated again and again. Okay, now this is the basic part of the whole circuit and this is repeated again and again. So let's solve this one, and how many times it is repeated, I will simply multiply it by that. Okay, this is a circuit consisting of this is 1 ohm resistance, this is another 1 ohm, this is 2 ohm, and this is 2 ohm. So let us draw the equivalent circuit of this mesh. It looks like, see, one resistance is connected to the junction here, and the second end of the resistance is connected to the first end of another resistance. That means they and this are series. So let me draw it this way: 1 ohm, 1 ohm, because they are in series. Now see this one. One end of the resistor is connected to the junction, another end connected to the second resistance. So that means these are also in series with each other. And of course they are connected to the junction. So this is 2 ohm and this is 2 ohm. Now the picture looks much easier. We can see these two are in series, these two are in series. So effective circuit of this will become 1 plus 1, 2, as they are in series. So we can simply write it as 2 ohm and 2 plus 2, 4, and this as 4 ohm. So our circuit, which was this complicated, now simply gets reduced to this circuit. Let us find the equivalent of this. Using the parallel formula, 1 upon R equivalent of, I'm putting 1 here because we are taking just one part of the whole question. It is given as 1 by 2 plus 1 by 4. That makes it 4. It is 2 more. Okay, so continue this. This is 4. This is 2 plus 1. That makes it 3 by 4. So 1 upon R equivalent, first part is 3 by 4. So R equivalent becomes, it is the inverse of it, that is 4 by 3 ohms. Okay, it is 4 by 3 ohms. Now we have 1, 2, 3 such circuits in the given question. So let's find the resultant. This is R equivalent of 1. Let us find the combined resultant. If we have 3, we will multiply it by 3. If we have 4, we multiply it by 4, and so on. Okay, so 1, 2, 3, 4 we have here. 4 into 4 by 3, that is 16 upon 3 ohms. So this is our answer of the question. This resistance has an internal resistance of 16 upon 3 ohms. Coming to this part of the question, let us try solving this also. Now understand this mesh. At one end, we are starting from here, the current moves inside, and this resistance R has one end connected to the battery and second end connected to the second end, and the second end connected to second end, and so on. This means this R is in series with this resistance, and this is in series with this, and all the resistances given are in series. So it is just a confusing diagram. It's very simple. Actually, we can draw it like this. Okay. Let me draw it. We have R like this, connected to another R, connected to another R. 1, 2, 3, 4, 5. We have 5 resistances. Okay, and it is a N. So you take this one, start from it. It is going like this, but actually it is this. So we can simply calculate R equivalent as R plus R plus R plus R plus R. That makes it 5R. So this is the answer of the given question.